afternoon, everyone, and welcome to today's EI Live K-12 session. This is a very special session, and I'm actually going to hand it over to a colleague, Marty, from the Columbia Alumni Association to tell us about why this is such a special EI Live K-12 session, and then we'll get started with our presenter. So Marty, if you can take it away.
Thank you, Cassie. Thank you, everyone. Good afternoon. Thank you for joining us for Columbia Alumni Family STEAM Week, our online iteration of the very popular CAA Family STEM Day. Today will be hosted by the Earth Institute through their EI Live programming. EI Live has put on 52 virtual programs since the start of the pandemic and has been dedicated to bringing the science of sustainability to you. I would like to thank our partners at the Earth Institute for putting on this program today. Today, we will be hearing from Dr. Alex Root, who received his degree from Columbia in biomedical engineering and is a member of the International Society of Computational Biology and currently a postdoc at Lamont Doherty's Diamond Microbial Oceanography Group. He studies how life works with from molecules to cells, to individuals, to communities, and is especially fascinated by cities and the oceans with their astonishing diversity of life. Without further ado, please welcome Dr. Alex Root.
Thank you, Marty. Welcome, everyone. That was a lovely introduction. I appreciate that. So hello. So welcome to my garden. Today, we're going to do a variety of things. I'm going to share my screen. So go ahead and take out your notebooks, take out your materials, and we'll get started with today's class. So I encourage you to take notes along with me. So I'm going to be using this Jamboard technology here. And so we'll do a little bit in today's class. And again, so please take notes. Let me lower this font. So please take notes so that you can better remember the material, better remember the science, and also to warm up your drawing skills, warm up your doodling skills. So in the second part, we'll do some doodling. So part one, I'm going to talk about plant science, specifically photosynthesis and the carbon cycle. And then I will also touch on the benefits of growing our green thumbs, i.e. gardening. And then in part two, we are going to do botanical doodling. And so I hope everyone brought their favorite plant or some cut flowers for today's workshop so that we can actually practice botanical doodling from life to improve our observation abilities. And as you guys know, the first part of the scientific method is observation. And so building our ability to do observation actually builds our ability to think and to do science, also to garden. Okay, so we'll go to the next page. Oops. And so I wanted to start by reviewing photosynthesis. So that's our first topic, photosynthesis. And this is how plants use light, carbon dioxide, and nutrients to grow. Okay, so we'll begin with black pen drawing here. So we'll just sort of draw the ground and a plant, and I'll make it sort of a baby plant, so just have two leaves, like so. And of course it has roots that we do not see, and those also branch similar to the plant. And then we'll change to yellow. So we could draw a sun. And of course the sun's rays hit a leaf, like so. And this is going to be the source of light energy that the plant will use. So the roots will gather nutrients and water and send them to the leaves. So we have things like water molecules here and nutrients. And I apologize for the construction noise in the background. That's a wonderful thing about New York City. We always have a lot of action. So we have water and we have nutrients that will come up from the roots, like so. So those are going to enter. Those will enter the roots and they will actually go up to the leaves through the plant. And the plant has a vascular system to move the nutrients and water, just like we have a vascular system in our body to move blood and other fluids. Okay. And from the air, the plant will use carbon dioxide, so it's CO2. And so this is going to enter the leaf as well, like so. And so let's go ahead and draw a molecule of carbon dioxide. So it's a carbon, which we can draw like a circle, and an oxygen, basically in an 180-degree arrangement. And typically we draw carbons to be black. So I'll just color this in black in the center. And again, it's a dioxygen. So it's two oxygens here, which we draw, often we draw them of red. And so we're going to need 6 of these to participate in photosynthesis. So go ahead and draw 6 carbon dioxide molecules. Again, so we've got a carbon flanked by 2 oxygens. Like so, and I'll color them in. So red for my oxygens. And then black for my carbons. Okay, so there's our 6 carbon dioxide molecules. And now we're going to draw 6 waters. And so water is H2O. So we're going to have our oxygen in the center. And this time, the little molecules here, the hydrogens, these smaller atoms, are at a bent conformation. So they're not at 180 degrees, which was the case for the carbon dioxide. So we have a kind of a different molecular geometry for our waters. And it's traditional to leave the hydrogen atoms, these little guys, as water. So you can see we have 2 hydrogens, H2, and an oxygen. So go back and color my oxygen red. Like a brush. Okay, so these are my reactants, 6 carbon dioxide and 6 water. And so I can do my reaction arrow here, like so. And now the light is going to be the source of energy for this reaction. So we can add the light here. And then actually doing a lot of the molecular rearrangements are molecular machines called proteins, and they function as enzymes. So we have these molecular machines that are going to rearrange the molecules into useful products. Okay, they're also called enzymes. Okay, so we have light energy here that's basically powering this chemistry, and combined with these molecular machines that do the reaction. Okay, and so we have our reactants on this side, and so we can draw our products. So what is going to happen is the 6 carbon atoms that make up these 6 carbon dioxide molecules are going to get joined together into a ring structure. Looks something like this. Now I'll color them in. with black. So here's my 6 carbons, like so. And the 6th member of the ring is going to be one of the oxygens. Okay, and then we're going to have side groups off of the ring. So we'll have an OH group here. And here we'll have an OH, and we'll have a hydrogen here and a hydrogen here. Here we have an OH and a hydrogen, and an OH here, and an OH here, and an O here. And let me color in the oxygen atoms red. Like so. And again, we'll leave the hydrogens white. So this is our molecule, and this is a sugar. And this is its general chemical formula, C6H12O6. And I'm sorry for the construction noise. Okay, and then we're going to have 3 oxygen atoms that are produced. So color these in. And so this is the oxygen that we breathe. This is oxygen gas, and it's a byproduct of this photosynthesis reaction here. So we have these 3 O2 molecules that are produced. Okay. And then after all this rearrangement, we're also going to end up with 6 waters like what we started with here. So there's 2. And I'll color these in red here. Okay, so in chemistry, reactions are often balanced. So the total number of atoms on the product side is equal to the total number on the reactant side. And so overall, this is a balanced chemical reaction. Reaction of photosynthesis is balanced. So there are the same number of each atom on the product side, on the reactant side, as the product side. So if we carefully counted the atoms, we'd see that we have 6 carbons on the left, 6 on the right. We have similarly the same number of oxygens on the left as the right as well. So the reaction is balanced. And the point is that the light energy from the sun is used by the plant to make complicated molecules that are nutritious, to make sugars that are used for energy and also as building blocks for growth. Okay, so that's the basic reaction of photosynthesis. So I mentioned that the plant will conduct water in nutrients up from the ground using a vascular system like that to power the leaves. And so similarly, the leaves are going to send the sugars that they produce from photosynthesis down to the rest of the plant and down to the roots here that I'm just indicating in green. And that's what the vascular system of the plants does. So we have, to summarize, at the leaf level, so we have carbon dioxide coming into the leaf, and we have oxygen and water coming out. Okay, so when the plant does photosynthesis, it actually loses water, and you can see the water's coming out the other end here of the reaction. And of course, it's replacing the water from the soil from the roots. So overall, we have a nice balanced reaction in photosynthesis. Okay, if you have any questions, you can please enter them in the chat. Okay, and I'll go on to the next slide here. So this whole process of photosynthesis participates in moving carbon from one form to another. And so we refer to the movement of carbon from one molecular form to the other, say from carbon dioxide to sugars, as the carbon cycle. And I'll talk about two main components of the carbon cycle. So again, if we switch to our drawing mode, switch to my black pen. Got my basic plant here, like a simple small plant with its root system. And we've got the sun with its rays powering photosynthesis. And of course, we have animals participating in this cycle. And so we have animals that are grazers, and I'm just going to sketch that out as a little sheep here. So of course, the animals eat the plants, and the plants also die. So at the end of this cycle, plants and animals return to the soil, where they are broken down by decomposers. And these are both bacteria and fungi that do this reaction. So we have decomposers in the soil, and they break down plant and animal matter when it returns to the soil. And that also then cycles back to nutrients that the plants can use for growth. Nutrients here. But sometimes some of the material actually bypasses the decomposers and goes further down into the earth. And over a process that takes millions of years, the material is compacted under high temperature and pressure, and it forms fossil fuel. And since fossil fuels are mainly carbon material, and the carbon material has a black form, we often draw them like this. So we have fossil fuels. Over millions of years, fossil fuels are formed. And so these are things like oil, natural gas, and coal. Let's move this over here. And so these fossil fuels are derived from photosynthesis. So they're really ultimately derived from energy that came from the sun. And we, of course, realized this at one point in history. So around the middle of the 19th century, so around 1840, we discovered that these fossil fuels have this enormous source of energy, and we built platforms, like drilling platforms, to go down very, very deep in many cases into the ground and extract these fossil fuels. Right? So this is my drilling shaft here. And so we have learned how to basically pump these fossil fuels out of the ground. And then we refine the fossil fuels into fuels that we can use on an everyday basis. So I can just kind of conceptualize this as gas. So we can go to the gas pump, for example, and refill our cars. So we use this gas for transportation. So just draw a little truck. And we also use it, of course, for flying. Both of these engines are similar. So in a jet, we have a gas turbine. So it burns the fossil fuel and it produces thrust on the end. And in the truck or a car, we have an internal combustion engine. We burn the fossil fuel. Either way, we release exhaust from that process. And then we also use fossil fuels to generate electricity, which I can kind of just schematize as a power plant. And so in this generation of electricity, we're also burning the fossil fuel to generate electricity that we then use for all kinds of other processes, such as running our air conditioners. And so this process of generating electricity, that's also burning the fossil fuel. And so our whole civilization is powered by fossil fuels and other sources of energy, but mainly by fossil fuels. And so this was a major discovery, a major achievement in the history of humanity for us to have discovered these fossil fuels, these very rich energy sources that allow us to do all of these things. So to summarize, so yes.
Sorry to interrupt you. Once you're done finishing up this slide, if you could go back to the previous one, we had a comment about how they were still copying something down from the slide. Thank you.
Sure, sure. So again, so we burn fossil fuels for transportation, to make electricity, and power our civilization. Burning them does the reverse reaction of photosynthesis, which we call combustion. And so we take something like a C6H12O6 plus 3O2, 3 oxygen, and that gives us back our 6 carbon dioxide and also produces water. So it's basically the reverse reaction. And the issue is that these processes are out of balance. And so before 1840, fossil fuels accumulated underground. And after 1840, Okay, I'm just going to go back to the previous slide because someone needed to capture something. Okay, we will post the video too if you want to go back and clean up your notes later. Okay, so the carbon cycle, unlike the photosynthesis reaction, overall is out of balance. And this leads us to our next point, which is the greenhouse effect. So to think about this, I'll just do a quick sketch here of the Earth and the atmosphere. And of course, we are on the blue planet. So if we sort of view our planet from space, we can kind of add a bunch of blue to it just to make a rough little doodle of the Earth here. And I can add some green as well. Okay, so again, so we have light coming in from the sun. And those rays come to the Earth, and many are absorbed and then radiated as heat off of the Earth. And some of that energy is radiated out to space, and some of that energy is trapped back to the Earth that warms the Earth. Okay, and this was called the greenhouse effect because it was first observed with greenhouses. So if we have a greenhouse, you can kind of sketch something like this. So in a greenhouse, of course, we often have a shelf where we're growing some plants, like so. So we have some plants growing in a greenhouse here. And what was observed in the 19th century with the greenhouse is that it's actually very effective at keeping plants warm. So we have the sun's rays here coming through the greenhouse. And the greenhouse, of course, has like a glass or a plastic roof. And so the light can come through and reach the plants. And then again, some of it radiates as heat and some of it comes out, but a lot of the heat actually is trapped within the greenhouse. The greenhouse traps heat, but allows in light. So it keeps plants warm. Okay, and in the same way as the glass of the greenhouse traps heat, carbon dioxide and other gases also trap heat. And because this effect in the atmosphere is so similar to what the gases are called, this is now known as the greenhouse effect. And so if we add additional carbon dioxide or other greenhouse gases to the atmosphere, so if we add more gases to the atmosphere through the burning of fossil fuels, for example, more of this light energy from the sun is going to be trapped, and that's going to warm the planet. So we get less light that's emitted from space and more heat that remains. Okay, and so that's the greenhouse effect. Now I want to draw a graph. So we'll make a X and a Y axis. Okay. And on the x-axis, we'll have time in years. And on the y-axis, we'll have the amount. And we can start this off, our graph off, around 1840 or so, so the start of the Industrial Revolution, when we started to use fossil fuels in a large amount. And we can end at the present. And so over this time, we have slowly used up fossil fuels. Let this line be our fossil fuels. Okay, so since the start of the Industrial Revolution, we've used up fossil fuels that had accumulated in the ground over millions of years. So their amount's gone down over time, whereas the amount of carbon dioxide we've put into the atmosphere has gone up over time. And so overall, this process is unsustainable because we are removing fossil fuels much, much faster than they accumulated. And we are loading the atmosphere with additional greenhouse gases that are warming the planet. Okay, so next I'd like to talk about heat and green space. And so we'll draw a little cityscape here. So, whoops, imagine we have a road. So, and along the road we have a building. So, and maybe we have another building off in the background. So we have sort of two buildings here, and we can imagine sunlight coming down. So we have light coming down from the sun, and it strikes the ground, and it warms up the ground, and then later gets radiated as heat. Also strikes the building, warms up the building, and gets radiated also as heat. So in this scenario, most of the energy from the sunlight goes into warming the road and the building. Okay, and let's draw another scenario. So now imagine the same situation, but we'll have some green space. So we've got a road. And I'll draw our buildings here. And again, we have sunlight coming in, striking the building, striking this building, also striking the road. But this time we'll have some greenery. So I'll sketch some trees, some bushes here in this backyard. And maybe we even have some shrubs or so on the roofs of these buildings. So we have some greenery all throughout the back. Maybe we have gardens, for example, planted between these buildings, or other types of green space. And so now the rays from the sun, they're striking the plants, striking the green roof here, striking this wildlife in the backyard. And as a result of this, the plants are blocking the solar energy and using some of it for photosynthesis. And as a result of this, we get a number of benefits. So for one, we get cooler buildings and temperatures. We don't have to run the air conditioning as much, so we have lower electrical bills and less energy usage for air conditioning. We also get wildlife habitat. So if you can imagine a whole series of these buildings and a whole series of green space, it provides habitat for birds that may be migrating, or for local birds that live here. It provides habitat for insects, for other things. Of course, we can also grow food and medicine as well. And then we also get beautiful surroundings. Okay. So at this point, I would like to go ahead and launch our first poll question for everyone that's participating. So our first question is, how much space do you have to garden with? Do you have a table or a window? Do you have a small to medium-sized outdoor plot, or do you have a large outdoor space? And of course, the amount of space that you have is going to dictate the type of gardening that you can do, but you can still do a lot, even if you just have a small space, like even if you have a window ledge, especially if it gets good sun, you can actually do a lot with your gardening as well. All right, so at this point, I would like to talk a little bit about building our observation skills with botanical drawing, and then we'll go ahead and get started doing a drawing. And so I can see the results. So many of you, looks like about 20%, you have a table or a window to do some gardening. About 40% have a small to medium-sized outdoor space, and about 40% of you have a large outdoor space to work with. So I see you guys have a lot of different options and a lot to work with. Okay, so again, even if you have a small space, there's a lot that you can do with it. Okay, so I thought for the amount of time we have left, we could do a little bit of botanical doodling, and I'll give you some general tips to go through before you guys go ahead and get started. And so the first part of the scientific method is observation. And there is a quote that says you have never really looked at something until you've tried to draw it. And I think there's a lot of wisdom in that saying as well. And so this is going to be our first tips here. I'm going to change to my plant cam. All right, so hopefully you guys can see my plant cam. And so I have a tomato plant here with me. And the way that you want to approach the botanical drawing is in step one, go ahead and rotate the plant or flowers to find a pleasing angle. So this is something where you can clearly see the leaves, maybe you can see the flowers. Just go ahead and get it oriented to where you're sitting so that you feel like you've got a pleasing angle at which that you might draw it. Okay, step two. We want to try to analyze it and think about simplifying. So, do we need to scale back and doodle a smaller part of the plant? So if you've got a very complicated plant that has maybe it even has multiple stems, for example, you may not want to try all of that in the beginning. You may just want to focus on a small part. You may just want to do, for example, one stem or even just one leaf. Okay, so you can look and simplify. I'd say if you have more than 10 leaves, you want to break it down to something smaller to start with, to start doodling with. Okay, step three, air tracing. So what I want you to do is take a pen or a pencil and trace the plant. So hold it in front of you. So to start with the container that the plant is in, for example, I can sort of trace this round pot that's holding my tomato plant here. So I'll just go ahead and trace it around with my hand. After you've traced the container or the vase that it's in, then go ahead and trace out the main stem, follow the curves in the stem, and look at the branching pattern, how it branches and diverges. Okay, and then go ahead and trace some of the leaves. And what I would recommend doing is starting from the front leaf. So in this tomato plant here, this is the one that's closest to me. So I can take a look at its shape and I can actually just go ahead and trace it with my pen to give myself an idea of what it looks like. All right. So we air trace to get an idea of what we're gonna sketch. And then step four, we'll go ahead and analyze the colors, light and shadows. So take a look, and it can help actually here to squint. So if you squint with your eyes, you can get an idea of what are the brighter parts of the plant and what are the darker parts. Okay, that's going to give us an idea of light and shadow. And then also take a look at the leaves and the stem. So in the case of this tomato plant here, the stem is a lighter color green. For example, on this side, it's a little bit darker on this side. And then I've got much darker leaves than the stem. I've got little hairs coming off of the stem here, and that the plant uses those for protection. And then I've got darker leaves with actually fairly complicated pattern of the veins on the leaf. So they're making a branching pattern here that's fairly complicated in this tomato plant. Okay, and then step five, we're going to go ahead and start outlining the plant. Okay, so I'll go ahead and do it along here. So this plant, for example, is in a nice large container with a lot of mass. It's got a really large, nice circular pot that it's in. The pot itself has a really nice lip. So this is a big terracotta pot. Go ahead and sketch that around. And it's okay if it's not perfect. Plant like so. So I'm going to outline the plant in black. So I've got my first stem coming up from this tomato plant here. Got one branch coming off like this. So you can go ahead and get a general pattern with the stems. Again, it doesn't have to be perfect. Okay, and then I would recommend, again, starting with leaves that are closest to you. And the tomato plant has a very complicated leaf shape. It's got a lot of bends and crenulations in the leaves. And typically when we doodle, we want to get a couple of leaves in fairly good detail, but not necessarily every single leaf. And if you look closely on this tomato plant, the leaves come off in branches and pairs. So at each point where there's a branch, there's a pair. So there's another leaf that's going to come out this way, front of the pair, and then there's another pair of leaves that come out here. And again, a pair. Small leaves. So I'll add another stem here. And this stem is actually really interesting because this one has some flowers coming off of it. It's actually some very small yellow flowers, and it's actually these yellow flowers that are going to turn into, in this case, cherry tomatoes. I hope we get some cherry tomatoes out of this. Okay, I can add some leaves. So in this case, right, every time I've got a leaf coming off the branch, I've got another leaf that's coming off together. So I always see these pairs of leaves. And again, you just want to try to get the basic shape of your leaves. All leaves are different. You know, all leaves have different shapes, but there is an overall pattern to those leaves. Again, here we typically have small leaves on the end. So it's a bit longer. Okay, and at this particular point, I've already got a flower that has begun to turn into a little tomato, and it's actually starting out as just a little ball. Whereas this one's actually a flower, and this one's a flower. Okay, at this point, go ahead and analyze your shadows, analyze your colors. And I usually start with the dirt because it's fairly easy. So I'm just gonna go ahead and start with the dirt mound that's surrounding this plant. It's not always traditional in botanical illustration to draw the pot and the dirt. Um, I like to do it. The soil is such an important component of the plant, and we care about various things in the soil, from the pH of the soil to the nutrients that are present in the soil. Because again, plants need nutrients, and different plants need different types of nutrients in different proportions. Some plants even change the color of their flowers depending on the soil. So in a hydrangea, for example, depending on the pH of the soil, it can have different color flowers. And then I'll go ahead and color in the pot. So in my case, I'm missing, well, the giveaway for this plant, which would really be the cherry tomatoes. If the cherry tomatoes were present on here yet, and I drew them in, people would be able to tell instantly what sort of plant this is. And that's one of the things that you want to capture in your drawing. You often want to draw it in a way that's it's realistic enough that if someone looks at it and they know and they understand the plant, that they'd be able to tell what type of plant that is. I'm not sure I've achieved that with this tomato plant today, but hopefully you have. Hopefully your drawings are coming along nicely. So I'll go ahead and just color in these leaves. And to get a darker color or a lighter color, you can press harder. In this drawing software, I don't really have the ability to do that. The best I can do is just get a nice transparent color in the leaves. And again, it's perfectly fine if your coloring is also a little rough, because there are all kinds of different shades and all kinds of different colors that you'll see. And of course, you can mix colors together. So in my case, my stem is a lighter color than my leaves. So I'm going to add some yellow to my stem. And then I'll add some green back to it. So get hopefully a lighter looking color green. And if you have a blue and a yellow colored pencil or markers, you can mix the blue and yellow together, and you'll get maybe a different green than the green that's in your set. And if you're really lucky and you have a lot of different colors in your set, then of course, you can use all of these different greens. And there's going to be hundreds of different shades of greens that we see in the garden, which is one of the joys of doing botanical illustration and drawing plants. All right. So this is my first doodle here. Oh, and there's the yellow flower. I wanted to make sure I added the yellow flower. So the yellow flowers are here, coming off the end here. Okay, and so for the next step, once you've kind of made your doodle, you can go ahead and record some observations. For example, you could record the date that you did the drawing. If you have a ruler present, you could record some measurements, potentially about the size of the plant, or just some qualitative notes. So in my case, here in my cherry tomato plant, whoops. Okay, so I would say today is Thursday, June 17th. And so I'm actually beginning to notice a small cherry tomato forming from one of the flowers. So I'm noticing noticing the first cherry tomato forming. And so this is frequently the case. So the definition of a fruit is it forms from a flower or from part of a flower. And so a tomato is technically a fruit because it's actually forming from the flowers. And that's also the case with a number of other things we think of as vegetables, but which are actually technically fruits. So if the structure is forming from a flower, it's technically a fruit. And in this case, I see this first cherry tomato forming. It's actually green. It's a green ball on the end here. And if I observe this plant on a regular basis, I can get an idea of how it's doing. And again, my apologies for the construction noise in the background. So these are some observations that I have about this plant. It was actually looking pretty droopy earlier today. It was looking like it was wilted, so I gave it some water and it perked right back up. So this is definitely a plant in this kind of container, which is ceramic. It will dry out on a warmer day like today. So it's actually very important just to make sure that it's getting enough water when you see them begin to wilt. Typically, with house plants, we have to be careful that we don't overwater the plants. And one way you can check is you can, stick your finger in the soil. And sticking our fingers in dirt is good for our health too. It's good for our soul to touch dirt. And in this case, it's nice and damp, the soil, so it doesn't need to be watered. All right. So if you guys would care to put your doodles up. We have a website that you can go to post your doodles, which is on Padlet. Let's see if I can put the link out for everyone.
I've just shared it in the chat box as well.
Okay, thank you.
Go to it. You will likely need to take a photo of it on your phone or a device that you're using. In the meantime, Alex, I can share mine. I was sitting here. I think I picked a plant that was probably too complicated with the leaves and it wasn't as easy to see. But I just did a quick doodle in my notebook here, if you can see it. And this is the plant that I was using that I had.
Can you hold up the doodle again?
Yeah. So let's see here. There's the doodle. And then, this is the plant itself.
Yeah, that's very complicated. It's got beautiful, what we call variegated foliage, which means, so that's definitely a challenge. You could certainly try that one again tomorrow if you want, with just doing one leaf, and see if you can convincingly get that variegation pattern. But it's always great to try things that are beyond our skill level. That's one of the ways that we learn, right? As we try things, and drawing is also about, or doodling is about, figuring out how do we solve these problems? How do we represent the colors and the textures and the shapes with what we have on 2 dimensions, of course, when we're drawing. So, thank you, Cassie, for sharing.
You're welcome. And if for those following along, if you we're going to keep that Padlet up for at least a week. So we'd love to see your drawings, and we actually have, so Alex, well, you can let them know, but we'll definitely keep those, that Padlet open so you can share your drawings, or you can email them to me and I will post them directly, on that Padlet site. And for those of you who have your hands up, just so you know, we're using the Q&A box. So if you do have a question, please type it into that Q&A box and we will get to that. So Alex, is there anything else you would like to, we're a bit short on time, and folks, thank you for staying on. If you do need to hop off, that's totally okay. We'll share the recording to everything. But Alex, I just wanted to make sure you, if there was anything else you wanted to cover before I launch into some questions.
No, that's fine. We can go ahead with the questions.
Great. Can we, if you want to switch back to your camera so we can see you, although your tomato plant is looking great.
Thank you.
um, so we have a couple of questions. So first question, does it have to have seeds to be called a fruit? This is an
So,
interesting question.
yeah, no, this is an interesting question. So there, you know, there's kind of the everyday English meaning of fruit, which usually means something that's sweet, you know, that we eat. And so in that case, definitely, that definitely doesn't. Um, in the strict botanical sense, I think most gardeners would say no. But usually they do have seeds to be called fruits. I think there may be some examples. Um, so if it's not a fruit, if it's not a vegetable, um, you know, sometimes we think of it as a nut. I mean, nuts are dried fruits.
Yeah. So interesting fun fact, I had been watching on Netflix Waffles and Mochi, and there was an entire episode dedicated to what is considered a fruit. And it was I learned that in order for it to be fruit, the seed is on the inside, except with the exception of a strawberry, which is also a
Mhm.
fruit, but strawberry we know have strawberries on the outside. So fun, definitely fun learning for me. So Shirley would like to know where you got all your plants.
Oh, from a lot of different sources. Some we've grown from seeds. So, for example, it's actually pretty easy to grow a potato. So this is a potato plant over here. I don't know if you can see this so well. So
Yeah.
we had a potato that was starting to grow some sprouts, so we didn't really eat it right away. And we had this large pot here, and we basically just buried the potato, and in not that long of a time, we've got these really beautiful, vigorous shoots. So it's fairly easy. You can remove seeds from fruits and put them in some dirt, put it in a warm, sunny place, and often you will get plants to grow. So that's a wonderful thing to try. I do like going to the New York City parks has a native plant nursery, and that's actually a wonderful place to go because with native plants, those are of course plants that are from our area. The birds, the insects, even the soil microbes, they're kind of used to the native plants, and so the native plants fit in really nicely with the ecosystem, and they help our insects, our pollinators, and the whole community sort of work together. So I do recommend native plants when possible. Um,
Great, thank you. And are there any doodling apps that you like to use for this specific purpose? And are there blogs about botany or plants and gardening, but also related to climate? Like, are there any blogs that you like and follow that you would recommend?
Yeah, I mean, I think on the doodling apps, I mean, I do like a Jamboard. It's jamboard.google.com. That's a pretty nice one. I think the doodling on Zoom is actually kind of nice. So if you launch a Zoom as the host and you share your screen, you can get on this whiteboard function, and that's actually fairly nice to draw. So I like both of those, and they're widely available. It's also nice, of course, to draw on paper as well. And Adobe makes a very fancy program called Adobe Illustrator that's extremely powerful, that's used by a lot of professional science illustrators for their artwork. So that can also be really fun to get into that too. And you can get a monthly subscription to Adobe Illustrator.
Excellent. Thank you. Let's check out the boxes here. Ethan, actually, this is a great question that we might wrap up with, which is more about sort of what can we do to help improve the planet? And perhaps, you talked about plants as one way that we can help perhaps control, at least absorb heat and energy from the sun. And if there are other ways for going green, and what can we do to help?
Sure. I mean, there's a lot of different interesting things happening with renewable energy. So these are sustainable energy sources. So things like
Sorry, everyone. Waiting for the construction noise. There we go.
yeah, the construction noise in the background. So certainly supporting green energy. So if you have a large space, you could potentially install solar panels on your roof, and that's a sustainable way of generating energy. If there's political candidates that are supporting things like wind energy, we can be involved in that. Of course, if you own a car or you need to get a new car, you could look at an electric vehicle, for example. Generally speaking, although electricity is often generated from fossil fuels, a lot of it's not. It's generated sustainably. So usually electrical powered vehicles are the way to go. Of course, you can try to lower your own carbon footprint by buying local food, eating local food, and I think just consuming less, reusing. I mean, every good that we buy is often shipped very far. So if we can reuse things and not always buy new things, and I think those are all ways lower our own consumption and footprint. And of course, some of the most energy intensive things we use on a regular basis is air conditioning. So if you're sitting in a classroom or office and it's super cold, we can ask turn down the temperature, open the windows. All of those kinds of things reduce our footprint. So those are just a few ideas.
Great. Thank you very much. And as I mentioned, we will be sharing the recording to all of this. Yeah, Alex, let's wrap up, and then I'll turn it over to Marty. But are there any other parting words you'd like to share with our viewers?
Well, I'd just like to encourage everyone to get outside, to garden. If you find a vegetable that you like or a fruit that you like, take out the seeds from that fruit. Like I love cucumbers, for example. So I can take out those cucumber seeds, plant them in some dirt, give it some sun, and hopefully we can all grow our green thumbs this summer. And I can't wait to see the doodles that you guys did. So.
Yes. Definitely. Thank you so much, Alex. I'm going to turn it over to Marty, and then I'm going to jot a few things down in the chat box for everyone to make a note of. You want to close us out?
Thank you so much, Cassie. Thank you, Dr. Root, and everyone for joining today. On Monday, we will be back for our final session of Columbia Alumni STEAM Week for a program featuring the Bio Bus about the power of 10. To register for this program and access event recordings and other virtual family STEAMed content, please visit alumni.columbia.edu/content/family-STEAM-week. And I believe Cassie is putting that in the chat box. Thank you so much for joining us, and have a wonderful evening.
Great. Thanks, Marty. And thanks, Alex. And thank you, everybody else, for attending. Take a look at the chat box there. I'll leave it there for a couple of minutes. The final link to the Padlet, or you could just email your doodles to me and I'll post it. And Alex and I will take a look at that. Thank you so much for tuning in. All right. Thanks, Alex.